Two engineers rewrite the same prompt. One types until it feels right, ships it. The other engineers 5 things, measures every change and ships it. Only one of them is doing engineering. Welcome, this is Module 3 of Get Started for AI QE in 2026, Designing the AI Test Input. I am Manoj Kumar. In 20 minutes, let's go. Every AI system in production has 4 quality layers. At the top, the human trust, how people actually interpret and use the output. Below that, orchestration, how components and tools coordinate. Then retrieval and context, what the model consumes, and at the base, how the model itself, and that's layer 1, right? Now here's the important bit. Failures move upward through these layers. And as they move up, they get harder to see and more expensive to fix. But everything layer 1 measures, whether the model followed instructions, whether the facts held up, whether the reasoning made sense, all of that starts with the input you sent it. So today, we work upstream of layer 1, before inference, because you can't test what you didn't engineer. QE gap. Code lives in a folder, right? It's an uncomfortable truth. Look at your code. It lives in a folder. Directory structure, every change is a commit, every commit gets reviewed. If something breaks in production, you can revert. Standard, boring, but works. Now look at your prompts. It's all strings inside your code, copy-pasted from Slack messages 6 weeks ago or a Copilot. No history, no review, no rollback. If something breaks, you don't even know what changed. And that's not something that you want to live with. Same shipping structure, different discipline. And that's the gap we will close today. So stay tuned. Here's a first move. Prompts should come out of your source code, out into a folder called prompts, sitting right next to tests, preferably, or however you want to make it. Every prompt gets its own subfolder, versions side by side, V1, V2, V3. There should be a change log. There's a link to the golden set. Same mistake that you put your tests in tests. Now, just prompts too. That's the only difference. Now look at the structure that I'm sharing with you today. That's the whole shift in one screenshot. If your prompts don't already live like this by end of next week, it should. That's your Monday move number 1. Now let's zoom in on one of the prompt files, right? 5 things every one of them has. The top of the file, the metadata. What is this? Version, the model, it should give you those informations. Below that is the runtime configurations like temperature, max tokens, same knobs the video 2 showed you earlier. Then a link to the tests, because a prompt without tests isn't shipped. Remember that. It's a draft. The body itself, right? It should show the structure, the role, the tasks. There are a number of formats that your prompt can have, and we will go through it in quite a bit. Examples, we build all the 5 in next few slides. And along the side, the change log, right? Every version, what changed, what the pass rate delta was, all of those information should exist. A quick note, if it's a Git-based approach isn't right for your organization, there are hosted alternatives like Langfuse prompts for commercial offerings and prompt layer. They give you a UI on top of the same discipline. The pattern is the same, but it's just plumbing changes. And if you really know what the discipline is, there are the tools and you can always engineer and make the process right for your organization. The thesis table, right? Here's what I want to slow down a bit and show you, because this is a money slide, right? And we want to take a deep breath and understand before we go deeper. Before we go deeper, I want to give you a table that's basically the thesis of this whole episode. 5 columns that you already know from your QE career on the left. 5 columns you're about to learn on the right. The test fixture, that's your system prompt, set once, applied every call. And video 2, B2, already showed you that mapping. Now test input, that's your user prompt, what varies per test case. Test contract, that's your output schema, what correct looks like. Test suite, that's your golden data set, the curated set you regress against, and video 1 built one already. Regression run, that's your prompt benchmark. Same as clicking run in CI. Look at this for a second. The vocabulary changed, the crafting. You already know how to do all of this. What's new is where you point at. The 5 patterns. So what does an engineer prompt actually look like? 5 patterns, let's go. Row, task, format, constraint, and examples. Role is all about who the model is. Task is what it must do. format, how the output should look like, because you want something from the AI. So of course, tell them what format you want. You don't want the AI to invent something you may not be needing. Otherwise, you'd be losing token costs, credits, and all of that. And constraints. So what it must not do. So don't invent new things, right? That's where the hallucination happens. And examples, right? Like text fixtures with worked out data. If you miss any of these five, and the prompt quality lives at the mercy of model's mood. So don't let it to the model's mood. Let's build them. Let's go pattern by pattern. Pattern 1 and 2, role and task, right? Who the model is, what it must do, right? Two lines that steer everything after. There's a continuation from a fixture pattern that we saw in video 2. So role. You're a senior QE triage engineer at a mobile-first SaaS company. Give your identity, you tell what the scope is, you set the domain, right? And that's what the role is. That's like a PyTest fixture of session scope, set once, applied every call, like a setup and teardown methods. Task. Given a raw bug report, it's one imperative, and verbs definitely matter there, right? Because given a raw bug report, as you see, classify severity, identify a component, extract reproducible steps, all of this. If you say, look at the report instead of classify, you get commentary. So you don't want to look that. And I'm sure I've done that. I'm sure you do. And if you're not doing it great, you're already a step ahead. Do not upload a file or a text and say, look at this report and share review. No, don't do that. If you say, do a few things, you get 5 different answers on 5 different runs. Vague verbs get you vague output. Same as in a test spec. Anti-pattern, multitask prompts. Same anti-pattern you have been catching in code review for years. One test that asserts 5 things at once. Don't do it there. Don't do it here either. Now let's look at the format, which is pattern 3, right? And in video 1, layer 1 asserts on the schema, and your prompt should ask for that schema, right? Without that, it'll give you unstructured results that doesn't matter to you, right? And that format instruction should be in the prompt itself. Return a valid JSON, severity 1 to 4 values, component a string, reproducible at least 10 characters. On the right, that's pedantic schema for B1. That's the exact thing your test framework will validate against, right? So treat it like that. If those two match, half of your failures never leave the model. That's not a small optimization on a scale. That's not a lot of layer 1 fails you never had to debug. Constraints, pattern 4. And this is key thing as well. What must the model not do? Never respond in a prose. And that's very important. If severity is unclear, return P2. Don't guess. Reject input shorter than 20 words. Never include the user's emails in every response. Every one of these is a negative test case you have been writing for 15 years. Now, it lives in the prompt itself. Same discipline, just different surface. But there are also 3 failure modes that I want you to test for. The ones even a well-written prompt trips over. 1. Lost in the middle. B2 covered this. Critical info buried between top and bottom. Model forgets it every time. 2. Instruction conflict. Your system prompt says always return JSON, but your user prompt may say, explain this to me like a story. The model picks one, but you lose. Don't confuse the model. 3. Overspecification. 20 rules on the same output, model freezes, or hedges, or ignores half of them, and you don't want it to. If your constraint list is more than 5 items, you are at huge risk. Prompt injection is a whole other segment on its own. Adversarial testing, red teaming, but not for today. Definitely we will cover something later in the series. So stay tuned. Examples, pattern 5. When a few shot earns its token cost, and 0 for obvious ones, right? So 2 to 4 examples for nuanced tasks. But here's a bit most people get wrong. Quality beats quantity. Ordering matters too. Put the closest analog example last, because recency biases the model's attention. The example it just reads is the example it copies. 2 well-chosen examples in the right order beat 5 random ones every time. And every example costs token. Budget them like fixtures. 40 tokens each. Under a tenth of a cent per call. Cheap on the other one, but 10,000 calls a day, small numbers compound. Next is reasoning techniques, a layer on top of 5, right? And here's where the momentum gets built up, right? And I want you to stay focused. Structure gets you a prompt. Technique gets you an answer. 4 techniques you layer on top of 5 patterns. So 1 is 0 shot. Just the task, no examples, works for obvious things. 2, few shot. we just covered. 3. Chain of thought. 3 words that change what model does. Think step by step, then output JSON. The model reasons before it answers. Huge lift on multi-step logic. Try this on a hallucinating prompt. You'll see difference immediately. 4. Self-critique. And I do this all the time. For high-stakes outputs, after answering, list one weakness. Revise if severe. The model checks its own work, costs more tokens, but earns them back on wrong is expensive tasks. And you will hear a lot of other names like Rice, CoStar, Crisp, React. Those are mnemonic subsets of what we just walked through. These package changes, the craft doesn't. Right? There are a multiple number of patterns that exist. There is a website called PromptingGuide.ai. It's run by dire.ai in the community reference. And I'll quickly show you how it looks like. All right, so here is the reference that I wanted to provide. It's called PromptingGuide.ai. So I go to this website. I will share this link in the description below. You can check at it. So it gives you almost everything that you want to learn and master around prompt engineering guide. I've used this in my early stages when I was getting started with prompts, and it really helped me to write better prompts, not just review and giving like one word answers and getting a very abstracted outputs. So now if you go to prompt engineering guide, so it gives you a various different set of prompting techniques that you see here, like zero shot prompting, few shot, chain of thought, self-consistency, tree of thoughts. A lot of things, a lot can be done within prompts to get a better output. So if you're an organization where you don't have access to different tools like LangChain, LangGraph to create agents, do not worry. Creating agents has become very easy these days. With just prompt engineering, if you're in an organization where you have just access to Microsoft Copilot ecosystem, or if you have access to GitHub Copilot, that's good enough to create an agent, right? And I'm sure you'd have heard about Agents MD, Skills MD as a way of creating different agents that lives within your repository and you can make it on-demand call. If you didn't know, don't worry, there is a plan to cover those. Now, coming back to this topic on prompt engineering guides, say for example, let's pick one, React. This is my favorite too. It introduces framework for React where LLMs are used to generate both reasoning traces and task-specific actions in an interleaved manner. And also there is a video that is sourced there, so you can actually check. And prompt training, again, this is my favorite. If you have different things to do, for example, you don't have to bring in everything in one prompt, so you can have like two or three prompts and then get an output from prompt 1, how you can feed that as an input to prompt 2, and output of prompt 2 as an input to prompt 3, so on and so forth. And all this can be done as part of a prompt engineering too. So check this out. I'm sure it'll be helpful. I hope that was helpful. Let's go into the next slide and see what happens. So context assembly, this order really matters, right? Now, where do all the 5 patterns go inside the prompt? So a quick call back to video 2 on slide 9. Go check it out in the description below. We give you a link for the video 2. Slide 9 is a lost in the middle, right? So model attend strongly to the start and the end of the context. And the middle is sometimes almost forgotten. So make sure you put the important things at the top and the bottom. So the system prompt at the top, constraints right after. You can give user message at the bottom. So have this mental model in your mind to have system prompt at the top and the constraints and examples and user messages at the bottom. Now, prompt bloat. So bloated prompts are cost bugs, information density. That's the concept, right? So every line in a prompt must earn its tokens. And that's very important. Don't just dump. For example, you can use Copilot or ChatGPT to improve your prompt. And it'll give you a wordy prompt. Probably you'd have written yourself in 3 lines, and the Copilot tools would give you probably 15 lines. It may look good, but sometimes it adds extra information that you may not need it. So you always want to review and take that out, because every word is a token. Every line in a prompt must earn its token again, right? Look at this, the before and the after, which is bloated and engineered. So before, 1200 words, padded, apologetic, redundant, about 1600 input tokens, 2 seconds of latency, and that gives you 87 grand a year, that 10,000 calls a day. But if you see the after the engineered one, 220 words, every line earns its tokens, 290 tokens, under a second, 14 grand a year, same pass rate, same output quality, $72,000 saved every year, just from cutting apologetic language. The token is a new CI minutes. You two said it, I'm saying it too. Here, it applies in this world of prompt engineering and AI. Prompt caching. This is a very interesting, right? There's a companion move to prompt bloat, right? If you ask me, is there a way to solve prompt bloating? Yes, you can engineer it. The idea is simple. So if the same prompt hits the model again, same text, same model, same temperature, you shouldn't pay full price to reprocess it, right? So provider caches it and you pay a fraction. Both major providers like OpenAI and Anthropic have this now. And let's look at it how. From an OpenAI perspective, they make it automatic, right? So any prompt over about 1000 token gets cache hit. Roughly 50% of your input tokens, no code change, just works, rolling 5 to 10 minute window. Anthropic does it explicitly. You mark the parts of your prompt with cache control block, cache hit, about 90% off. Cache write costs about 25% more the first time, but you make that back on the second call. Now, this may change. We are talking about providers. They may change at any point in time. So I always want you to, at least now that you know this, go look for cache control block in Anthropic and look for latest updates. And so does OpenAI. When they release a new model, check how prompt caching is done from them. Now, if you supplement the QE angle to it, the cache hit rate is like a metric. Put it on your dashboard. If your system prompt is stable and your cache hit rate is at 15%, something's really wrong. You're paying full price on repeat traffic that you should not be doing it because of that prompt caching techniques. And this is, again, this video is Monday move number 4, cache aggressively. Now with actual mechanics. Every prompt change gets a changelog entry. Look at this one. So version 1, initial version, 65% pass rate on a golden set. And version 2, split role from tasks, tighten the schema block, pump to 7. Version 3, split constraints from format. Added 2 few short examples. It cut 3 redundant sentences. 89%. Same discipline as git blame on your source code. Every change is measurable. Every improvement is defensible. Every regression caught. This is what turns prompt from a string into an engineered artifact. Now, how do you test all of this? Let's extend the cascade that we have seen before. A quick recap on the previous videos in the series where we talked about this cascade. If you haven't, I highly recommend you to go and watch. So video 1, B1 gave you 4 layers, which is schema, properties, model gradient, and human samples. And video 2, B2 added 2 more, which is cost, budget, and latency. B3, video 3 added 7 and 8, which is prompt regression and context invariance. Let's look at prompt regression. 3 techniques hide inside one. Snapshot tests, same input, hash the output, cache shift. Golden set replay exactly what video 1 built. And property-based tests, faker or hypothesis generating input variations, all that can be done where model output must satisfy the same invariance every time. Same input class, same output shape. And layer 8 is context invariance. Is the schema being requested? Is the total input under token budget? Does the assemble context have the structure we expect, right? This is a PyTest running before the LLM call and not after same shape as it was first in 6. Same discipline, just a bigger surface. Same instinct that wrote the first 6 wrote these 2. Now let's look at it in live. I have a sample repo that I want to show you on how you could have this like a video 3 prompt bench. And as I mentioned, I will open source this for ardent followers of this channel. Unfortunately, I'm not going to publicize this, but if you really want it, please reach out to me. All right, then let's look at B3 prompt bench repository, which I'll upload in GitHub. So I'll open source it in quite a while. You can take a look at it later. But before I put it on GitHub, and if you're impatient, if you wanted to look at it, please feel free to ping me. I'll be more than happy to share with you a direct private repo link. All right, let's walk through this. So this is a runnable companion to the video, and it has a neat README file that shows you how you can run it and gives you a simple skeleton of how you can extend and scale this as you go. The things that I wanted to focus on is the bug reports. For something like bug reports, somehow you can organize. The things that I want you to do, 3 versions of the same prompt. Each is a markdown file with the YAML front matter as you see, version 1, version 2, version 3. As you see, it gets evolved, and also the change log that you wanted to focus on is how it started. So initial version, 1 imperative was no structure, and the golden set pass rate was about 65%, and version 2 is from 65 to 78%. Improvement was there, And then version 3, as you can see how we added, which moves to 89%. If you see how we move from 65 to 89, that's where the key changes. So this is what typically you do of Copilot or anything that you have access to. Summarize this bugs report into JSON with severity, component, and reproducible fields. While this is straightforward, it's useful for LLMs to give us the better output. So in version 2, we split the role from tasks, added a format with the exact schema. No examples, but it just gives you the so role, tasks, format, and then by report. And then V3 improved the prompts with a much more meaningful format with role, tasks, format, constraints, the one that we spoke about, the examples, and all of that. Now, every change has a delta, how we improve from the accuracy, right? Now, I have something called runbench.py, which is testing the different things, which I'll just show you by running it. Yeah, so this is running on a simulator mode and have an actual LLM call to run it, but here's what I wanted to focus on. So same golden set from video 1, which runs prompt version through layer 1, 2, 7, and 8. So what's the pass rate, as I mentioned, that moves from 67%, 77 to 87%, gives you a clear format. Let's me zoom this in a bit for you. So yeah, I think you can say run bench, missing recommended section, role, task format, and this one has added a bit, so it gives 77%, but still the L8 construct invariance is pass, and version 3 as you see here. So yeah, I think it gives you a complete version of how the improved IDs in the net delta and stuff like this. So as I mentioned, the goal for you is to move out these prompts into a different folder and have it one versioning on them, and then have something like runbench.py to run an audit check, more like a lint check, an audit check, right? You know how the delta is moved up and gives you that placeholder value. Yes, it will cost a little bit of token, but end of the day, it really helps you because it gives you that audit trail that you always wanted. Maybe on the version, so just flip the example, right? So on video 1, you may be having 20 lines of prompt, which Claude or Copilot gave you. Now, as you walk through this video, you know every word, every token is a cost. You may be now refactoring that. If you run the same thing, version 2 with the engineered, remember the before and after that I showed you. So now if you have the after effects on version 2, you can see things change as well. And surprisingly, it might improve your results as well. Yeah, so that was a quick demo. So let me flip back to these slides back again. All right, so I hope the demo was helpful. Let's move into the next one and let's look at the table again, right? So from traditional quality engineering to AI infused quality engineering. So every column is checked. Just a look back at it, right? So same 5 rows we opened the episode with. Now every right column has a green tick. So test fixture, you built one with role and task. Test input, the raw bug report, the test contract, the format section, test suite, the 10 example golden set from video 1, regression run video 1 to video 3 measured, right? Regression run V1 to V3 measured. The vocabulary change, the craft tint. The same line from top of the episode. You just did the work behind it. All right, so 4 things Monday morning. 1, move one production prompt into prompts folder, just one, out of the source code. 2, rewrite it using 5 patterns, role, tasks, format, constraints, and examples if you don't follow a pattern. 3, attach 3 input golden set. Start small, grow as edge cases bite. 4, version it, commit it, track the pass rate delta on your next change. That's it. 4 moves. Doable this week, and none of this is theoretical. Now that you can engineer the input, the next video will teach you the model to look things up, right? Retrieval augmented generation, layer 2 of the 4 quality layers. Because prompts can't cover every fact. Sometimes the model needs to be fetched. Video 1 evaluated the output. Video 2, you see what's happening behind the scenes, the LLM calls. In video 3, this video, we looked at how do you engineer those outputs with the prompts. And in the next video, we are looking at things to add more context so you get the better output. Stay tuned in video 4. Until then, take very good care of yourself. See ya.